All right, so for this problem, the first one, this is trying to see if behaviors of birds that were searching for the seeds and insects in the Oregon forest to see if the percentage of trees is the same as the ones where the birds were seen. So if they didn't prefer certain ones, then the percent that was in the forest should be the same percent occupied, essentially. Where do we start? I might want to start on the second one. I don't have it written down. Yeah, we'll go and start here. Where do I start with state? I'm kind of going to go out of order here. What is our null hypothesis? What do I need to do before null hypothesis? After proportion. What would this be? Proportion of what? Thank you. And was it all birds? So what is our null hypothesis? And I would kind of need to do a key here because it wouldn't really make sense without one. I would probably do just 3 of them, right? And then so I would have that P subscript D is what? 54%. Some people don't like to use the subscript P because that looks kind of funny, and that's fine if you want to use something else. This would be 40%. And my last one, which I don't like using because that's confusing because it's P naught. I might do something like that. That's totally up to you if you want to do it that way or not. But that way I'm not going to be as confused with having strange subscripts. And then so what do you write as your alternative? And then this one did not give us alpha, correct? I know I'm still skipping population right now. What's my first part of plan? This is a my next part. Check conditions was my first condition. Where does it say something about random in this problem? This is kind of a weird one to say. that's not how we usually write it, but I have selection in there, so that's really fine with what we need. What else? What do I actually write beside of that? So then you should actually write your chart here. How do I find what my expected counts for Douglas firs are? What do I need first? My total. So I've got 70, 79, and 70, and 70, 79, and 7 for a total of what? 156. So you're not writing this out, but this would be 156 times what? And I'm just going over this more in detail because it's been a while and I didn't write this out before. So this would be 156 times 0.4. This would be 156 times 0.06. But what you actually get, what's my number here? 0.2 what? This one ends up being, and so you don't actually need this line. That's just a reminder of how we got those. And then so all of those are greater than or equal to 5. So that's all we need to write there. And then my last condition is what? Which is 10% condition. So this is why I haven't done this one yet, because this is kind of a weird problem. What was my N for this problem? 156 what? Birds. So now that I know that, what is my population? Because some people think it's the trees, and that's one way that you can kind of check yourself or correct yourself if you did do that, is when you get to here. So I'm doing 10% condition. My N is 156. So 156 times 10 is, and I would need to say, assuming, or there are, and then what? Questions on that one? All right, so this one I probably wouldn't shorthand my chi-square part just because it's only 3, right? The first and the last one, that doesn't really seem to help that much. How do I find my degrees of freedom? How many categories were there? So my first observed was 70. My first expected was what? Wait, did I get this in there? Yeah. What was this one? And we end up getting a chi-square value of what? I don't have this written down.
1.4.
1.8 what?
2.
What's the shape of chi-square always look like? Which way do I always shade?
Right.
And when I use my test in my calculator, it's going to give me my p-value, which has a p-value of what?
0.244.
244. Which means this is less than, so our now much shorter hand conclusion, we what? And I can just write this because that's long and I've already written very clearly what that is. Which means that we and again, I can just write that and stop there. Now, the second one, I'm not going to go through writing out the entire problem, but there's one main thing that's different about it.
You don't have to write the rest of that, HA.
Because it is on there. So for number 2, all of this stuff, P would be what for the second problem? Proportion of dice roll for each outcome. Probably wouldn't need a key there because it's really obvious, but then it would, so how would this look different for number 2?
P1 equals P2 equals P3 equals P4 equals P5 equals P6 equals 1/6.
So all of them are claimed to be the same. This would still be the same. We'd still have an alpha. So when we do expected here for number 2, what do we get all of our what was our total number of rolls? So this is 90. So 1/6 of 90 is going to be your expected value for all of them. Expected number of counts for all of them. So I always have people that see something like this and they're like, I don't know how to do it, but this should be a lot easier. It's just that all of the expected happen to be the same. What I'm kind of talk through these. It's still chi-square goodness a fit. What would be random about that one? Every dice roll, every roll of the die is random. What would it be for 10% condition with there would be at least 900 what? The die can be rolled at least 900 times. What would you get for number 2? What do you get as your chi-square value? 14 point what?
4.
What was your degrees of freedom?
5.
And you get a p-value of what?
0.132.
0.122.
32.
Which means that we do or do not. We do. So this is going to end up being the exact same because we don't have any context in here. This would be the exact same for number 1 and number 2.
If we have a 2